This is right where we were yesterday. Let's get this done. Um, so we had gotten to this example, and remember we talked about the fact that there was an X missing from one of the equations. So what was our strategy? Right. Remember when you get these, they're not very common, but when you get one where there's a missing variable, make sure you kill the same variable again. So again, even if there were a temptation somewhere else that was better than the X's, like if you had a negative 4y and a plus 4y, don't take that low-hanging fruit because having X gone in one and Y gone in another does you absolutely no good. So what we're going to do is we're going to multiply. I think we had gotten this far. We had said we'll multiply the top equation by 3 and the bottom equation by 2, right? So by doing that, what we create now, and we can honestly just leave this middle one out of it because he's going to be part of our 2x2 system. So we're going to get a new little kind of 2x3 or 3x2. I'm not sure what order to say that in. So this top equation is going to say negative 6x plus or minus 3y. Sorry, go ahead. Mm-hmm. Nice. And then the bottom equation is going to be 8y plus 8z equals negative. Perfect. And again, I'm just ignoring the middle guy. I don't feel like I even need to copy him over because he's just not part of this. Like he's already ready. He's kind of waiting for his partner. And we're about to create that partner by combining these two top and bottom rows together. So normally it's a good idea to copy the whole system back over. But in this case, like I said, there's really no point. You can if you want to. So if we add downwards, what do we get? No X's. Mm-hmm. 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 And then what we're going to do is we're going to take the one that was already good to go, and we're going to transfer it over to complete the 2x2 system. So sorry for the color mismatch, but that's the idea. So when you get a system where one of them's already down a variable, he's just kind of going to wait for you to create another one just like him. And then this system down here, this 2x2 over here is now our priority, right? So now we go back to the olden days and we have a simple 2x2. There's probably an answer that most people would pick, but which are you more attracted to eliminating, the Y's or the Z's? Probably the Y's. The Z's, you'd have to turn them both into 85s, which, whatever. But the Z's, you could just turn them both into 22s. Okay, so we're going to take now and multiply the top one by what? Mm-hmm. And the bottom one? Yep. And again, we don't have to use signs here because the negative 11y and the positive 2y, they're already staggered one of each. And so we don't have to manipulate signs, which is great. So we create now a new 2x2 system, which is negative 22 plus 34z equals. Uh-huh. And then the bottom one. 22y. Yeah. 55z equals 110. Perfect. And so now we can commit to this and do our combination. So when we add straight down the line, how many Y's do we get? None. Good. How many Z's do we get? Negative 21. And then when you add your constant terms together, what do you get? Nice. Then we divide both sides by negative 21 and figure out that Z is good. And again, the same, I'd said this wouldn't take very long. The ending is always the same. You work your way down to a 1 by 1. That's a 1 by 1, one variable, one equation. And that's where you'll get the first piece of useful information, which is that Z is negative 2 for the intersection point of the planes. And then we have to find Y next because Y is the part of the 2x2. So Y and Z will work together first, one to find the other. So there's an obvious answer, I think, to this question. Of the equations you see up here, who's the best choice? Clearly the white one, right? Because it's not wrong if you don't pick it. It's just sensible. Numbers are smaller. We always increase our odds if we pick smaller numbers. So that top equation, that's this one with the egg around it, is going to say 2y plus 10. Love it. Right. Subtract 10. It is going to be 0. Right. So we get a second piece of the puzzle. Make sure you put it in the right spot. And then this is where Y and Z, lock elbows and join forces and go back to the original problem. So there's only one equation in the original system that you couldn't use. And I would venture to say that it's pretty obvious that it's this one that I've been moving around, this white one that only has 2, because it doesn't have the variable that we're trying to figure out, which is X. So at this point, I'd probably, yeah, and you could go so many different ways with this, but that one's just fine. So if we're gonna substitute some numbers in there, the only one that's not gonna change is the X because, well, that's what we don't know. So we have negative 2X. And then if we put in our 0 for Y, the Y term just goes away. And then 3 times Z is 3 times negative 2. So that's, yeah, minus 6 equals negative 8. So that's, again, just the equation at the top of the board in the red oval. It's just that equation having Y and Z substituted in and then recopied. And then from here, it is going to be 1, right? And that's just algebra that you're just not allowed to mess up at this point in your educational career, right? If you add 6, you get negative 2. And if you divide by negative 2, you get X equals 1. And that's the flow, right? So if X equals 1, then you complete the puzzle, put a big old proud box around that. Like that's what we're working for, is finding that point in 3-dimensional space where 3 planes touch each other, which is that. Another example that you don't need because I think you get it. So we'll cut it off there. The rest of the day today, you have a worksheet. I'll hand it out to you, and that's what you're going to work on. Got it? Sure, that'd be great.